If you build aerospace test equipment, you're almost certainly under pressure to deliver systems faster and cheaper. In fact, between $100 million and $200 million and thousands of hours of effort are spent annually just to develop the electronics component of aerospace test equipment. This inefficiency acts as a drag on innovation industry-wide. So today, we're going to talk about the common design patterns and test systems that lead to these inefficiencies. We'll talk about modular, off-the-shelf hardware platforms that can mitigate those inefficiencies and how combining that into a comprehensive system architecture can drastically reduce the amount of NRE and time necessary to deliver one of these systems. What we're talking about here is test equipment, but what's really important is meeting the requirements necessary to certify your product. And that means putting an electrical spec on the pin of your product and getting a result in a qualified software environment. What we have to do in between those two things is traditionally what we would consider test equipment. Getting that test requirements coverage involves two components. First, you have to route the signal source through an integrated test system to where it's measured. And second, you have to take the appropriate measurement for the type of signal that you're working with. Let's take a look at how this is typically done. Now, at a very basic level, every integrated test system has a mass interconnect that usually goes to some terminal blocks inside of the system that connects to a standard, say, data acquisition platform like VME or PXI that's running some standard software suite that you use to qualify your product. Now, the first thing that every customer does is put signal conditioning on the line, and that's because there simply aren't enough off-the-shelf options for the types of sensors that you find in the aerospace industry. So right off the bat, you're spending your own time and money building something that everyone in aerospace needs. Now, depending on the type of testing that you're doing, you may want to interrupt the line with, say, open faulting, or drop the line down to a power bus. If you're building an integration lab, you may want to have the real component that's under control in the lab as well as the control electronics, and be able to switch back and forth between the real and simulated versions of those things. Also, because the test system is supposed to determine whether there's a problem with the product, you're very often going to want some kind of breakout box or test interface at the boundary of the test system so you can determine whether or not a problem is being caused by the test system or the product. And finally, if you're doing environmental testing or some types of integration testing, you may want a 4-wire sense system that comes back into the system that goes to either to a concurrent data acquisition system or drops down to an instrument grade measurement. So let's look at some of the ways we can use modular, off-the-shelf hardware platforms to reduce the complexity of building one of these systems. If we're looking for ways to make the system less custom, the obvious place to start is where we already have the most off-the-shelf components available for use. At NI, we use our PXI platform for the measurement and software components of the signal chain. This provides a lot of value, as having a single, comprehensively tested platform allows you to immediately reduce the risk and have a better starting point for the system. But as you know, most of the NRE and time you're going to be spending on the system is going to be through the customization necessary to make up for the lack of off-the-shelf components for signal conditioning and routing. That's where SLSC comes in. SLSC is a companion platform for PXI that allows customizations needed to build a system to be designed in a standard way. This enables an ecosystem of vendors to develop all of the different types of signal conditioning most needed in the industry, as well as standardizing the way custom implementations are developed for any particular system. What you see here is a fully populated SLSC chassis, and pay close attention. What we have with SLSC is the opportunity for all vendors creating products for this platform to use the same set of standards. For example, as you see here, every SLSC card has the same connector. That's intentional. One of the biggest cost drivers within a system is the point-to-point wiring necessary to map the interfaces of all the different off-the-shelf components. But we've gone a step further than just having the same connector. We actually have the same pinout on every card, regardless of the type of signal that's being implemented. That allows us to route signals around as groups instead of individual wires. So the entire system can be connected with modular off-the-shelf cabling. The last step in getting the test coverage you need is applying those internal signals to the pin of your product. NI has created several off-the-shelf mass interconnect panels that aggregate the standard cabling within the system and provide a high-density interconnect for a cable harness to your product. What you can see is that we can specify the entire signal chain from the unit under test all the way back to software using all modular off-the-shelf components. Taken as a whole, this is a comprehensive architecture where we have standard components for every single type that you have on your product. Now what we can do is synthesize the entire test system design simply by knowing the interface of the product we're connecting to. The product requirements become the test system requirements. Instead of designing a test system, we can configure one. Instead of doing a bunch of point-to-point wiring and custom drawings, we can assemble off-the-shelf hardware using standard cabling. So what this is going to do for you is give you back all that time and money that you're spending duplicating effort between test systems so that you can focus on what matters more, your product. To recap, most of the duplicate engineering that's going into each one of your test systems comes from the point-to-point wiring and customization that you're doing largely because there are no off-the-shelf components to implement the I/O types that you need in your systems. We've created a comprehensive architecture of standard component libraries that will allow you to synthesize a test system design directly from your product requirements. For more information, visit us at ni.com.